Well, hello, and thanks for joining me. We're going to go through a quick little bonding activity today. It'll serve as a good review of what's going on. There's an activity you can do at the end for practice, and I'll kind of go through the answers with you if you'd like to see those as well. We're starting out here with a representation of a potassium atom as this pink rectangle, and this bromine atom as this blue smaller rectangle. Now, what I'm going to do is take a pair of atomic scissors, and I'm going to cut out an electron from that potassium atom. Now that potassium atom is going to donate that electron over to the bromine atom. So when that happens, you can see that electron moves over. Now what's going to happen is that potassium atom is no longer an atom, but an ion. And the bromine atom is also no longer an atom, but an ion. So what that means to us is that the name changes. Br1 minus is no longer called bromine, it's now called bromide. And the potassium atom is now called the potassium ion. Now, those two fit together quite nicely. The potassium lost an electron to get a positive charge, the bromine gained an electron to get a negative charge, and they fit nicely together, and that gives us the compound potassium bromide. This is an ionic compound made from a metal ion and a nonmetal ion. Let's look at some more. So, and the formula, of course, for that would be KBr, 1K and 1Br. So again, we started with atoms, then we removed the electron and transferred it, forming the ions that then got together. All right, well, let's take an alkali metal like magnesium. Now, magnesium's in group 2, so it has a 2 plus charge, and notice it has 2 electrons removed from it. Now, if I were to add simply one bromide to that, this is not going to be neutral. It's going to have a 1 plus charge. So instead, I would need to add 2 bromides to that to make all the pieces fit nicely together. The name of that, of course, would be magnesium bromide, and the formula MgBr2. Now, it also works if I take a potassium ion, and let's take a bigger anion like oxygen. That's a 2 minus. Now, notice 1K and 1O doesn't make this work. I would need 2 K1 pluses to work with that oxygen to make this come together, and then that would give me the formula K2O, and we'd call that potassium oxide. Okay, let's try a few more. In this first one, hopefully you can see this would work. KBr, that would be just fine up there. And the second one would be K2O, that's fine. MgBr2, ALN, even though you have a 3 plus and a 3 minus, because they have the same charge, they get right together. Don't write it as Al3N3, it's just ALN. Here we have calcium sulfide, CaS. Now, notice here we can put in a polyatomic ion. So I have ammonium ion and nitrate ion. Putting this together would form ammonium nitrate. Now, in the bottom right corner, I have copper 2 with hydroxide, another polyatomic. So this would have the formula Cu parentheses OH2, and it'd be named copper 2 hydroxide. Now, clearly this one doesn't work, does it? We'll come back to that one here in a second. All right, so if you took an Na and an OH, that would form together. If you have an Mg, it would take 2 OHs to make magnesium hydroxide. Now, I could put any metal here with a 1 plus charge with a nonmetal with a 2 minus charge, and the way it's setting it doesn't work. I would need 2 of the metals with a 1 plus charge to make that work. Right? And then that would have the formula M2N. Or I could have just as easily put an alkali metal, a metal with a 2 plus charge in there with my nonmetal, and it would have worked. Now, if we have aluminum 3 plus and a nitride 3 minus, that goes right together, ALN. If I take a calcium, what could I put in here? Well, I could put a nonmetal with a 2 minus charge, or I could put 2 OHs, or I could put 2 Cl1 minuses. A whole bunch of different things could fit in there, couldn't it? Now, Let's look at this one. We looked at this earlier and said this is a problem, Pb with a 4 plus and an N3 minus. So if we take the Pb 4 plus and N3 minus, we would definitely need more negative charge. So if we only have N3 minus, we'd put another one there. Now we need more positive charge, so we put another lead. Now we need more negative charge, more positive charge, more negative charge, and finally get to what we want. Now the formula for this would be Pb3, there's three of those, N, 1, 2, 3, 4. So Pb3, N4. We could have got that by simply crisscrossing the charges. Now, what is the name of this? Well, the stock name would be lead, Roman numeral 4, nitride. Now, in the old system, lead is either 3 plus or 4 plus, and 4 is the higher number, so it's going to get the ic ending, and lead comes from the Latin plumbum, so this is going to be plumbic nitride. Okay? All right. There is, if you want, a little activity that you can do related to this. The answers for it, of course, are going to be right here. When you go through, there's the first 5 or 7, and there's through 11, and 12, 13, 14, 15, 16. Now, I want to just point out on 13. 13 is not correct. It says the answer is PB2, S3. Notice it's PB2, but it's not S1, 2, 3. It's S4. Now, I can hear you, even though you're watching this video much later than I'm writing it. You're like, that's still not right. I know. I want you to see that. PB2S4 can reduce to lowest terms. So it's really PBS2. So make sure you, thank you. Make sure you reduce those to lowest terms. Okay? All right. Just to remind you, single charge cations are group 1, group 2, silver, zinc, aluminum. We're not worried about these other ones in red here for our class. The variable charge metals are all the ones in yellow. And then in a binary compound, this group 17, are going to be -1, group 16, -2, and group 15, -3 for the nonmetals. All right, last thing I'll show you is just maybe the worksheet for that. So there is a chemical bonding activity. It looks something like this. Hopefully it's in your packet. Again, you're welcome to do that if you want for practice. It's not required, okay? All right, well, have a great day. Hopefully this didn't take up too much of your day. Bye-bye.